The learning goal for this lesson is to multiply two binomials. Multiply two binomials. Remember that multiplication of two lengths results in an area. For example, we have here a 5 by 3 rectangle, or 5 centimeters by 3 centimeters, and we notice that it's been broken apart into smaller squares. And each square is going to be 1 centimeter by 1 centimeter. And together, the area of each one of these squares is going to be 1 centimeter squared. And we have 15 of these smaller squares, which gives us an area of 15 square centimeters. We also notice that 5 centimeters times 3 centimeters is 15 centimeters squared. So now we're going to try to multiply 34 and 25 using the area model of a rectangle. So here we simply represented the sides of a rectangle with the numbers that we're trying to multiply. And we represented each 10 with the blocks shaped like this, and each one with a smaller square block. And we have 30 plus 4 here, and 20 plus 5 here. And when we try to multiply this, we can break it apart into smaller rectangles. And so we can make this first square here, which is a 10 by 10 square, as 100. And we can see that we have 6 of these blocks here, all 10 by 10. And each one of these is going to be 100. And to move on to the right side here, we have a 1 by 10 block, which multiplies to 10, and we have 8 of these. And on the bottom, we have these similarly shaped 10 by 1 blocks, which have the same area. And we have many of these. We have 15. And in the bottom right, we have 1 by 1 blocks, which each have an area of 1. So by now, of course, you've noticed that this is an extremely tedious process, and we could add up each one of these smaller squares, but we can also move on to the simplified form, where we write our 30 plus 4 here and our 20 plus 5 here, and we see that 30 times 20 is 600, which matches up with our 6 100 blocks, and 4 times 20 is 80, and we have 8 10 blocks over here, as well as 30 times 5 being 150, and 4 times 5 being 20. And now adding 4 numbers is a lot easier than adding these 1 million numbers over here. And adding these gives us 600 plus 80 is 680, plus 20 is 700, plus 150 gives us a total answer of 850. I think it's still paused. Oh no, it's not. Okay. Now go ahead and pause the video and discuss with your neighbor what happened over here. Now go ahead and pause the video and discuss what happened in this example with your neighbor. Alright, here's one for you guys to try. In this example, we're going to try to multiply 47 and 52 using the area model, and then using the simplified form. Now go ahead and pause the video and try this one. Let's see how you did. So using the area model, I have the 40 plus 7 on the top and 50 plus 2 on the left. And each of these 10 squared blocks over here, we have 20 of them as represented inside the simplified form of 2000. And then we have 350 over here with 35 10 blocks and 8 10 blocks on the bottom with 80, and then 14 1 blocks over here. And then together these all add to 2,444. So now we're going to introduce a new term. A binomial is an algebraic expression with two terms added or subtracted. Again, a binomial is an algebraic expression with two terms added or subtracted. And reviewing the example here, multiply 3x plus 4 and 2x plus 5 using the area model. And notice that 3x plus 4 is an algebraic expression with two terms added or subtracted, so it is a binomial. And 2x plus 5 is also a binomial. And now we have our square, or rectangle rather, and we can write out the 3x plus 4 on the top and the 2x plus 5 on the left. And now instead of 10 blocks, we now have x blocks, and these are all the same. We can still make our squares here to make the first square, and x times an x is simply x squared. And we repeat this process for each x blocks there is. And now we move over to the right side, where we have 1 times x, which is simply x. And we have 8 of these. And on the bottom, we now have x by 1, which is still multiplying to x. And we have 15 of these. And finally, we have our 1 blocks, or 1 squares in the bottom. So now, once again, we could count these if we wanted to, but we can try using the simplified form again, where we have 3x plus 4 here. And 2x plus 5 on the left. And we can multiply 3x by 2x to get 6x squared, and 4 by 2x to get 8x, and 3x by 5 to get 15x, and 4 by 5 to get 20. And notice that these all match up. We have 6x squared blocks here, 8x blocks here, 15x blocks here, and 21 blocks on the bottom. And if we add these four numbers as we did before, we have 6x squared plus 8x plus 15x plus 20, and these are like terms, so we can group them to 6x squared plus 23x plus 20. So now pause the video and discuss what happened here with your neighbor. So now we have another definition here. A trinomial is an algebraic expression with 3 terms added or subtracted. A trinomial is an algebraic expression with 3 terms added or subtracted. And our answer to this multiplication, 6x squared plus 23x plus 20, is a trinomial because there are 3 terms. And Remember that you have to first combine like terms before counting how many terms there are. Here's one for you to try. In example 4, we're going to try to multiply 4p plus 7 and 5p plus 2 using the area model, and then using the simplified form. Now pause the video and try it on your own. Let's see how you did. So what I did first with the area model is that we have 4p plus 7 on the top and 5p plus 2 on the left. And I drew my p squared blocks, my p blocks here, my p blocks on the bottom, and the 1 on the bottom. And then using the simplified form, we have 4p plus 7 and 5p plus 2. So 4p times 5p was 20p squared, 5p times 7 was 35p, 4p times 2 was 8p, and 7 times 2 was 14. And then we finally have 20p squared plus 35p plus 8p plus 14, which simplifies to 20p squared plus 43p plus 14. So for the mid-lesson check, I'm going to ask you, how are examples 1 and 2 related to examples 3 and 4? Pause the video and discuss with your neighbor what you think. So in example 5, we're going to go back and check our work in examples 3 and 4 using substitution. So if you remember example 3, we multiplied 3x plus 4 and 2x plus 5 to make a trinomial here, 6x squared plus 23x plus 20. And in order to check our work, we're going to first substitute in x equals 1 for both the binomials and the trinomial. So when we're multiplying 3x plus 4 and 2x plus 5, if we substitute in x equals 1, 3 times 1 is 3, plus 4 is 7, and 2 times 1 is 2, plus 5 is also 7, and 7 times 7 is equal to 49. And moving down to the trinomial, 6 times 1 squared is 6, plus 23 times 1, which is 23, plus 20, which gives us also 49. And this basically tells us that we can be reasonably sure that our answer is correct. Here's example 4, where we multiplied 4p plus 7 and 5p plus 2. And go ahead and check it yourself using p equals 1 with your neighbor. Let's see how you did. So I substituted 1 in for the binomials, and I got 4 times 1 is 4, plus 7 is 11, and 5 times 1 is 5, plus 2 is 7, and 11 times 7 is 77. And then moving down to the trinomial over here, 20 times 1 squared plus 43 times 1 plus 14 is the same as 20 plus 43 plus 14 equals to 77. So here we have example 6. I'll do part A for you guys, and for B, C, and D you can try those on your own. So we have 3y minus 8 on the top and 5y plus 1 on the left here. And 3y times 5y gives us 15y squared. Negative 8 times 5y gives us negative 40y. 3y times 1 gives us 3y. And 1 times negative 8 gives us negative 8. And to add these all together, we have 15y squared minus 40y plus 3y minus 8. And we notice that we have to combine these two. So we actually have 15y squared minus 37y minus 8 for our final answer. And to check this, we can substitute in 1 here at the top, and we have 3 times 1 minus 8 gives us negative 5, and 5 times 1 plus 1 gives us 6. They multiply to negative 30. And then here we have 15 times 1 squared is 15, minus 37 times 1 gives us negative 22, minus 8 is equal to negative 30. So now we can be reasonably sure that our answer is correct. And for B, C, and D, once again, pause the video, and discuss with your neighbor after you finish. Let's see how you did. For part B, we have 6p minus 5 on the top and 2p minus 3 on the left here, which gives us 12p squared minus 10p minus 18p plus 15 because we have two negatives, which gives us a final answer of 12p squared minus 28p plus 15. And checking our work, we substituted 1 at the top, and we have 1 times negative 1 is just negative 1. And 12 minus 28 plus 15 is negative 1. And moving on to part C, we have 7w plus 5 on the top and 7w minus 5 on the left, which gives us 49w squared here, 35w on the top right, negative 35w, and negative 25. And we notice that 35w and negative 35w add out, which gives us a final answer of 49w squared minus 25. And checking our work, 7 plus 5 is 12, 7 minus 5 is 2, so 12 times 2 is 24, and 49 minus 25 is 24. And now finally, we have 8m minus 7 on the top and 8m minus 7 also on the left, which gives us 64m squared here, negative 56m in the top right, negative 56m here, and 49 here, which gives us a final answer of 64m squared minus 112m plus 49. And checking our work, 1 squared is 1, and 64 minus 112 plus 49 is also 1. So I want to highlight C and D as being special cases. If you notice, 49 is 7 squared and 25 is 5 squared, so we can call this one a difference of squares. This occurs when we have two binomials that are the same first term but a different second term. And here we notice that we have 8m minus 7 squared, and we typically just call this a binomial squared. As we finish the lesson, I want to remind you that our learning goal was to multiply two binomials. So now I have some wrap-up questions here for you. How is multiplying two binomials related to multiplying two two-digit numbers? How does multiplying two binomials result in a trinomial? What does a difference of squares look like? What does a binomial squared look like? Go ahead and stop the video and discuss with your neighbor.